In our second Coulomb's law example, we'll go about it in a slightly different way. We're given two charges, a positive 8 microcoulomb charge on the left and a negative 5 microcoulomb charge on the right. We're not given that center to center distance, but we are told that there is a 5.75 Newton force between them, and we can determine that it's attractive because it's a positive and a negative charge. So they want to know what the center to center distance between these two charges currently is, because there's only one center to center distance that will result in 5.75 newtons of force between these two. So much like we've done in our previous examples, we're going to first list out all of our given information. We know that K is always 8.99 times 10 to the ninth. 8 microcoulombs and negative 5 microcoulombs respectively are those values times 10 to the negative 6. That's what micro means. R is unknown, and this is where we have to be very careful. Because we're told or we determine that it's an attractive force, we have to plug in negative 5.75. Remember, the negative implies attraction using Coulomb's law, not leftward or direction. So this is an attractive force. I have to make sure that I use negative 5.75. Otherwise, I'll get kind of one of those weird answers where the negative doesn't seem to make sense. All right, so the next thing we're going to do, we only have two charges, so we will use Coulomb's law exactly one time because there are two charges in Coulomb's law. So if we plug in what we're given, the negative 5.75 and the K value and the two charges in coulombs, then what I can do is I can try and solve this for R. So I'm going to simplify everything. You can go about this a few different ways, but in this case, I multiply 8.99 times 10 to the ninth by 8 times 10 to the negative sixth by negative 5 times 10 to the negative sixth, and that's what gave me my negative 0.3596, and obviously that's over R squared. Again, you can go about this any way you like. I'll try and go through in whatever order I looked at. I then multiplied both sides by R squared, and then divided both sides by negative 5.75. That's how I isolated R squared by itself. So you determine R squared is 0.063. And then if I take the square root of both sides, you'll find that these two charges must have a center to center distance of 0.25 meters or 25 centimeters between them.